Yes, class. Am I audible to all of you?
Yes, ma'am.
So all those who have joined are Amna, Austin, Deborah, Fadil, Fia, then Humam, Hussein, Tarif, Rajita, Shahid, Sidra, Shavez is joining. All right. So yes, class, let us quickly complete with this portion of reflection. We have to start with refraction also. So in till the last class, what all we have seen? We have seen the basics of reflection. We have seen the laws of reflection, right? All the laws of reflection we have seen. Then we had seen mirror formula also. Sign convention and all that was done before that. So I'm not discussing this again, all this. In the last class, we had seen how to draw mirror images, right? And if an object is there, light strikes on it, then how will you draw the image? That is what we had seen. And one very important relation and derivation, which I told you that this derivation does come in your exam, is relation between the focal length and the radius of curvature. Basically, radius of curvature, this is double of the focal. If focal length is present, you just put two focal lengths together, that will give you radius of curvature. So this derivation is important, class. This derivation, it will not come in your long answer questions, section D and all that you have. It won't come in that. This will come either in your 2 marks. Usually this comes for 3 marks. What I have seen in the regular papers, and even if you take out your previous year questions, and especially in the pre-boards, I have seen in the school exams, pre-boards, this question comes relation between focal length and radius. Easy question it is. So the derivation is also not difficult. In your lengthy questions, no, the derivation of the mirror formula comes this, because here it won't stop over here. It will ask you the sign convention. It will ask you the conditions for linear magnification. So this becomes a huge proper 5-marker question for you. All right. So prepare mirror formula also, but obviously all the derivations you have to do. In any ways, all the derivations you have to do. Start whenever you are thorough with a chapter. Suppose we are done with, let's say, current electricity, for example. All of you have completed current electricity, right? One time we all have done it. On a regular basis, on small durations, we all have done. So when you are about to set, what you do, take all the derivations which are present, list it down. Like the first derivation, drift velocity, write it. Relation between drift velocity and current, second one. Like they just write down all the derivations that are present. Fine. Do them, because one of them will come, or if it comes, then you shouldn't lose marks in the derivation, because derivations are, these are things which are already present and you know the answer. You don't have to do any calculation, right? Then the definition part. Definitions, all the basic definitions only come. You don't have to write thesis on the physics exam, right? It's not bio or any other exam. You just have to write one liner only. Ohm's law, definition of current, basic statements, Ampere circuital law, like this basic statements you have. Fine. Then, because already from the derivation, you are thorough with maximum formula, right? You're already done with most of the formula. Then whatever portion is left, like the numericals and all, keep on start practicing them whatever time is left, because numericals have no end, right? So this is how you should go about in the exam also, whenever you are preparing. So when we are talking specifically about ray optics, you all should be thorough with these two derivations till now, including linear magnification. Two, when I say, it means we are including linear magnification. Fine. Now see, this question says that an object is placed 10 cent. Okay, two parts are there. First part is the object is placed 10 centimeters. Second, 5 centimeter. So first one I'll discuss. Second one you all will practice. All right. You all will tell me the answer. So in front of the concave mirror of radius of curvature 15 centimeter, find position, nature, magnification of image in each case. Means you have to tell everything. You have to apply entirely what we have left in the last class. So let us start with the first part itself. Object distance is 10 centimeter, 15 centimeter radius. Okay. See, object distance will be minus 10 centimeter. Do not take it as 10 centimeter. Why? Follow the sign convention. Mirror is there. Concave mirror, it is mentioned also in the paper. in the question. Object is kept in front of the mirror. This separation is 10 centimeters. So if the separation is 10 centimeters, total it will be minus 10 centimeter because this is kept in front of the mirror. By just looking at your data, someone should be able to deduce all the figure, right? Your data should be so accurate. That's why we are performing sign convention separately. So minus 10 centimeters. Radius of curvature is mentioned, not the focal length. Do we need radius of curvature? We don't need, but radius of curvature is helpful. That focus is half of radius of curvature. So if radius of curvature is 15 centimeters, this will become 7.5 centimeters. Now this is also not correct. Why? Negative sign. Because focal length is also formed in front of the mirror. Focal length is there in front of the mirror. Like object distance, this is also a length only. So this will be minus. Please be careful with the sign conventions class. One thing remember, object distance will always be negative because it is always kept in front of the mirror in opposite direction to the incident ray. But for focus, you have to be careful because we know sometimes focus lies behind the mirror in case of convex we had seen and all. And more than focus, image you have to be careful with because images can be formed anywhere. So be careful with images. In any ways, we have to here find out the image distance, so we don't have to worry about the image distance initially. Whatever will come according to the sign convention. Then you don't have to apply your mind for the sign convention. Because right now you don't know what type of image is being formed. When the object is kept in front of 10 centimeters in front of the mirror, you do not know what type of image is formed at which position, virtual, erect, or real, inverted, which type of image, right? That information will be given to you by the image distance first. For the position, we have to find out image distance. Now, since we have already substituted the sign convention, whatever our answer will come, it will already come following sign convention. Do you get it? If my answer is coming minus something, it means image is formed in front of the mirror by this separation from the pole. If I say plus something, means image is formed behind the mirror. So whatever my answer will come, that will tell some nature of the image by itself. So 1 by f is equal to 1 by v plus 1 by u. This formula all of you should remember. So from here 1 by v will be 1 by f minus 1 by u, right? So here we just have to substitute all the values. So 1 by v will be 1 by focus is minus 7.5 minus object distance was minus 10. So this becomes minus 10, 7.5. So minus 2.5. And that is 7.5 into 10. 0.5 into 10. So 1 into 3, 25 and 75 if you take. So this becomes 30. 1 by 3 into 10, this becomes 30, right? Leave 10 right now. 25, 75. This becomes 1 by 3. This 10 is already there. So this becomes 30. So do we need this? We require V. This is 1 by V. This is like your equivalent resistance in your current electricity. 1 by R equivalent we were obtaining, or in your capacitance, 1 by C equivalent we were obtaining, right? So here you have to find out V. So what will be the value of image? See, image is minus 30 centimeters. Minus sign is telling you the fact that image is formed in front of the mirror. Firstly, this is clear. So now with our answer is already getting minus sign. It's already getting minus sign because we have already taken sign convention. That's why I'm saying if you take improper sign convention, answer will be completely wrong. It will be completely different. Had we taken focal length here positive, our answer would have been positive and our answer would have been wrong. So just be careful with the sign convention. Just take a little time while you are writing. Once you are done, just analyze the sign convention and all. Once you are done with that writing part, whatever things are given in the question, whatever things are mentioned in the question, then you are free. You just have to perform mathematical calculations, right? One more thing. We still do not have everything about it. So what we do for reflection, we have the formula minus V by U. So minus, what is image? Image distance is minus 30. So you won't put it as 30, This minus sign is for the formula. You have to put minus 30 by u is minus 10. So that becomes minus 3. Now class, minus 3. Now we'll apply whatever things we have studied in the last class. Firstly, magnitude. Magnitude means you have to ignore the signs, whatever signs are mentioned. Plus, minus, just ignore it. Take the number. What is the number? Number is 3. Is it greater than 1? Number is 3. 3 is greater than 1, less than 1, equal to 1. It's greater than 1. Right? So what all conditions? Please take out that table which you have written. Very good, Shaviz. All of the 3 are correct. These are the conclusions which you have to write. Very good. So, enlarged, firstly, magnified. The image is magnified. Wherever you people have written, no, in the last class, just take it out. At least you will have an idea what am I saying. Magnified. Firstly, because magnitude is greater than 1. Secondly, now come to sign. Now come to signs. Signs are negative. So negative shows it is inverted. Sign basically, this tells you about real and inverted image. So it's real, it is inverted, and it is formed 30 centimeters in front of the mirror. This is the whole information which we have to substitute. No, not table Fia. In the last class we had written, no, this you should remember, you people should remember. See this one. All of you remember this. This will be helpful for all your numericals. So magnitude was greater than 1. So we had taken images magnified. Now magnification was negative. So image is real and invert. This is how you have to solve all the questions. So this part I have done. 10 centimeter part, 5 centimeter part, all of you will submit me in the chat column right now after writing this. Copy it. 5 centimeter you all answer. All of you, most of you have given the answers. Some of you still haven't. Shahid has given. Amna has given the answer. Rajita has given. All the three answers are different. For the second one, image is of, okay, this you're telling the answer. Same size virtual erect, so value you must be getting, no, Fadil? Let me discuss it now. If you people still are solving, some of you all can answer in the chat column. Second part, see, same things you have to do. It's just that the object distance is given as -5 centimeter. Why minus? Because it is kept in front of them. Okay, Deborah, not just the value. What all conclusions you'll, because the question is not to tell you the value of magnification, right? You have to tell the way we are written, real, inverted, magnified, like this. Chavez, same thing. Till magnification solve. 1 by v will be 1 by f minus 1 by u. So again, 1 by f is minus 7.5. This will be 1 by minus 5. So this becomes minus 5. In right straight away, this will become I think till now only Amna has answered it correctly. Let me check. Okay, minus 5 minus this we are getting minus 7.5. Here we are having 7.5 into 5 is there. So 7.5 is there, 5, 3. So 115 into 1. So 1 by 15, right? Yes.
Ma'am, shouldn't it be 1 by minus 7.5?
1 by, yes,
Minus.
7.5 only. While I was calculating, I've written minus 7.5. Then only you will get minus. Here I just missed it while writing.
Yes, ma'am.
Minus 7.5 because focal length we are taking for the same mirror. So then only it will come minus 1 by 15. 1 by 15 is there. So V will come 15 centimeters. Who all have answered? Chavez, V15. Deborah, 15. Rajita, minus 15. No. 15. And centimeters, not meters, Rajita. Rest fine.
Ma'am, it is minus 7.5 into minus 5, right?
Which one, Fia?
The last one, before the last step.
Minus 7.5 into
Denominator.
minus 5. Yes. Minus 5. This actually I hadn't written it properly because here LCM we are taking. So orally only we have to solve it. Minus 5 minus 7.5. One more minus will be there, no? So yes, it will come out to be 1 by 15 only, no? See 2, then 3, so 30. So 1. So 1 by 15. 1 by 15 only it should come. And you all are also getting 15 centimeters only. Then
Ma'am, it's 1 by V, right? So wouldn't V be minus 15?
Shahid, minus 15. You people are getting minus 15 also. Minus. See, minus is there. Minus 15, how are you getting?
No, ma'am, because 1 by V, right? So V would be minus 15.
Rajita, you are not audible. Please just write it, Rajita.
Ma'am, am I audible now?
Shahid, it's 15, no? Yeah, it would be 15, Rajita. Plus 15 it would be. When we take the focus, see, minus minus here, it will be positive, no? Look, I'll write it properly over here. It's unclear. Yes, Rajita, 1 by V is coming 1 by 15. Right. So V will be 15 by 1. That is 15. See, here this minus 5 is there. Minus 7.5. That becomes plus 7.5. Right? That becomes plus 7.5. Now see, in the denominator, when we are writing, in the denominator, you are having minus 7.5 into minus 5. So this will be, instead of writing this minus and instead of writing this minus, whenever you are putting multiplication and you are solving it, that becomes, how do you write it? Ultimately, it would be plus. So to be precise and to clearly write it, I'll write it as 7.5 into 5. Minus sign will already be present, because now it would, what would happen? It would be more clear to all of you. Now tell me, in this, which sign convention you people are not understanding? Okay, magnitude you are answering. It's fine. Yes, see, don't write just the magnitude. No, when you are writing the image distance, that's what I was telling you in the last before this part. Here, when you are solving, whichever answer you people are getting, this image distance will give you information. If you are getting it positive, that will tell you image is formed behind the mirror. Like in this case, this is coming plus 15. So it will tell you, right, that image is formed behind the mirror. All right. So if you will by yourself not mention the sign convention and just consider the magnitude, so that would be that won't be sufficient information for you. All right. That won't give sufficient information to you. All right. So this is how we'll solve it. 7.55, 2.5 you will have. Here you will have 5, 7, 3, 37.5 you will have 15 centimeter. Now, here the answer is still incomplete. As I was saying, this won't give you the information, every information about the image that we want, right? We have to put in okay, magnification, you are getting it. See, just check it once again. One out of all the 3 which you have mentioned, Fia, I am referring to you. 1 is incorrect. Other 2 are fine. 1 is incorrect. Look at the portion which I have made you write. So see, this becomes minus V by U. So minus 15. And this is 5 we are having. So this becomes minus 5. So this becomes plus 3. Not 1.5. V by U. 15 by 5 we'll write. Fine. So this is plus 3. Now, some of you, actually most of you have obtained this 3 fine. You people have obtained 15 centimeter also correctly. Problem lies here. Like Fia, diminished. It cannot be diminished. Magnitude, you yourself have written this 3, right? So if you have written this, then you should know the magnitude is greater than 1. And magnitude is greater than 1, then it won't be diminished. It would be magnified. Signs are positive. That will tell you that yes, it is virtual, it is erect. Fine. But magnified, it won't be. Now see. Shahid has obtained it correctly. Fia, again that diminished problem. Otherwise, you have written it
Yes,
correctly.
ma'am. Got it, ma'am.
Got it. Deborah and Chavez, the details. All right. Your image distance was correct. You have to write these conclusions because the question was focusing on this. So 15 centimeters behind the mirror. Second one is of same size. Same size it is not. So Fadil, yes, Fadil has corrected himself also. Rajita, I have already mentioned. Amna, you didn't mention the size, enlarged or diminished. All right, just add that. Shahid is also corrected. All right, class. This completes with the reflection initial portion. Write it down. Write down this part, all those who haven't written it. Then I'll start with the refraction. Completely, this is not over reflection. You will have total internal reflection also, but that is a part after refraction only. Let's start with refraction. Yes, enlarged. Correct. Write it down, all those who haven't. Then we'll start with refraction. Basics of refraction we'll see. Please just write done in the chat column. Then I'll start with refraction. Now class, the next topic, refraction. So see, in reflection, the major topics, the major portions that you had were this. Now everything will be combined. First, let us focus on refraction. Most of the topics are based from refraction. You have apparent depth, you have concept of total internal reflection also. That is a part of reflection as well as refraction. Now, what is meant by refraction? Refraction is a very simple phenomena. A surface is there. This is a surface, an irregular random surface I have to take in. Now, on this surface, if a ray of light strikes, its work was to pass like this, right? If it goes like this, that will be reflection. That process is called as reflection. Instead of going like this, it either goes like this or goes like this. Means whatever was its original path, it deviates a bit or more from its original path. That phenomena is known as refraction. Bending of light also you can say. Bending of light rays, or you can say deviation from their normal path. Deviation from normal, original, from their original path. All right, this is what is meant by refraction. And what is meant by this? Rectilinear propagation of light. Rectilinear propagation of light basically means that light travels in a straight line. When you have taken a blockage, light will travel in a straight line. This is the property of a light ray. Whenever we are talking about light ray, this is the property of the light ray. It will travel in a straight line. If you have the path like this, light will go straight. If you have the path for the light like this, instead of going like this and then reaching the final destination, this will go like this and will stop and form the shadow or image, whatever is necessitated over here, like this. Some very, very small rules you are having right now. The rest of the details we'll study it later. Principle of reversibility. Principle of reversibility is what? Principle of reversibility is also easy. It's just that, see, which part, Chavez? Light one, light, propagation of light. See, propagation of light means, linear propagation of light means light travels in a straight line, right? Like this, see, this is a straight line. Suppose this is the path of light. If I have this as the surface, so light will come, it will strike like this. But if I have my path in a curved manner and I want it to just curve and bend and curve and bend, that won't be possible for light rays. Like this is not possible for this pen. If I have to, it will be slanting, but this will be always in a straight line. So that is what is meant by linear propagation. This means here, suppose these are two blocks that I have taken, two blocks, and this was a wall. Light would have gone straight away like this. Here I have taken two blocks like this and two more blocks like this, which are blocking the path of the first one, right? The orifice of the first one. So when the light rays will come, instead of going like this and then turning and then turning and then finally reaching the wall, no, they'll just form the image over this point only, because it follows rectilinear propagation of light. That is what is meant by rectilinear propagation of light. Next, I was telling principle of reversibility. So principle of reversibility. Okay, one thing class, in the first class only we had discussed about the meanings of incident angle, reflected angle. So I'm not repeating it. I hope you understand when I say angle of refraction. Angle of refraction is also made between the normal only. Not from the surface, not from the path. It is made from the normal only. The way reflected angle was made, how much? The normal was taken, right? The normal was taken and the reflected ray between them. Similarly, refracted ray and the normal, that is angle of refraction. Now see what is meant by principle of reversibility. Suppose there is an incident ray. This is an incident ray. Fine. So according to the laws of reflection, whatever angle of incident has been formed between the normal and the incident ray, angle of incidence equals to angle of reflection, and this light ray gets deviated, right? It gets deflected. So this is not very proper. Please just draw it with a proper scale when you are writing in your notebooks. So this reflected ray of light becomes incident ray for this next part. Again, reflection will occur. So reflection will occur. This will move onto the next mirror. Fine. Now this will also move to it. Now see what is happening in this case. This is an example so that you understand what is meant by principle of reversibility. Look here. This is the incident ray for this mirror. 1, 2, 3, 4. For the fourth mirror, this reflected ray of light is the incident ray. This is the incident ray for this. What is the angle of incidence? All of you. Answer me in the chat column. What is the angle of incidence according to you? This angle that is formed, this is striking perpendicularly. What is the angle of incidence? Fia has answered. Others? Only Fia has answered. This angle between this ray and the surface is 90 degrees. Very good, Chavez. Any other answer? Austin, your answer. Rabia, Rajita. What is the incident ray? I have discussed incident ray is the angle formed between the normal and the incident ray. Only Chavez and Fia have attempted. Whatever answers you feel, at least tell me whether they are correct or incorrect, that I'll discuss it. But you should be able to at least answer it. Austin has also answered. Others? See, answer is correctly given only by Chavez. It's 0 degree. Class, this is the incident ray. How do I make the normal here? Normal is this. Retracing it. This is the normal making an angle of 90 degree with the plane. Angle of incident ray is also striking normally. So what is the angle between the normal and incident ray? Normal is also here. Incident ray is also on the same path. Both are overlapping each other. 0 degree. Fine. So if incident ray, if such a case happens, light ray, instead of following another law of reflection, because see what happens. If incident ray is 0 degree, according to the laws of reflection, angle of reflection will also be 0 degree. Angle I is equal to angle R. So if angle I is 0 degree, angle R will also be 0 degree. So light ray will reverse back. Now, what is principle of reversibility? Suppose this was a situation and this happened. Principle of reversibility says that if light ray is retracing its path and it has already covered so many reflections, it has already suffered several reflections, so it will retrace the path in the exact manner in which it had been incident on it. So this will go like this, it will strike here, it will go like this, it will strike here, it will go like this, it will strike here back. This is what is meant by principle of reversibility. This principle states that if the final path of the ray of light, after it has suffered several reflections and refractions, is reversed, means the path is reversed. It retraces its path exactly. Fine. Now some more basic points, just the basic points. When we are talking about objects, object basically means a source of light. Fine. So objects are actually of two types. Objects can be luminous. Now what are luminous objects? When I say source of light, so luminous also, like this tube light. This tube light is a source of light. So it is emitting its own light. It's emitting its own light. All the bulbs, lamps, lights, street lights, tube lights, everything. These are luminous objects because they are able to emit their own light. Next category is non-luminous. Now, if I am able to see the screen of my laptop, this is emitting its own light. Fine. But what about the keyboard which I'm able to see? Keyboard is not emitting its own light. But why am I able to see? The thing is that this is a non-luminous object. This is acting as a non-luminous object, not glass. Keyboard is not, my keyboard is not made up of glass. Not glass.
No, ma'am, no, not like that. I thought like non-luminous object, like they can't emit their own light, right? So I thought glass will come under it.
Glass for non-luminous. See, every object is non-luminous, which is not emitting its own light. That's what I was saying. See, suppose this screen is able to emit its own light. That is a luminous object. But this keyboard is not emitting its own light. So it's a non-luminous object. Now, but still we are able to see every non-luminous object. If I talk about my phone, this part, this screen part, this is emitting light. I'm able to see this part as well. No light is being emitted from here, right? So why? Because right now, if I'm able to see this, light from the luminous object strikes and then it goes into the eyes. Then within the eyes, lenses are present. Then again, refraction phenomena, entire phenomena occur. So refraction is occurring in your eyes, right? So in that way, you have luminous and non-luminous objects. This is not a very important topic to be discussed in detail. Just remember, luminous objects and non-luminous objects exist. So Fia, which you were mentioning about glass is also non-luminous. Glass does not emit its own light, but it helps in refraction and reflection. Now, when we are talking about real object and virtual object, this also you should remember, because if just light rays are mentioned, how will you identify? I'll just tell you one trick that is very helpful in identifying whether an object is real or not. If you see light rays are diverging from an object, if this is an object that is kept, the light rays are diverging rays. It means a real object is kept. Real object does not mean virtual object does not mean a fictional object which you are imagining. No, real object is an actual object which you have kept. Suppose this phone, I have kept it in front of the mirror and I'm able to see its reflection. Fine, that is a real object. It's a physical entity. Now what happens? Suppose here an image was formed. Let's say somewhere because of the rays, an image was formed. Fine, a virtual image or whatever image was formed, and one more mirror was kept. Now from this object, light rays will again move because one more mirror is being kept. So what is happening? Is there an actual object for this first mirror? This first mirror, I had an object, and light rays intersected and gave me an image. This was object, this image was obtained. For the second mirror, the first image is acting as an object. So first image is not a real image, it's a virtual image. If I'm getting a virtual image and that is acting as an object, it means it's a virtual object. Means actually it's not an object, and virtual does not mean fictional, you are imagining. Fine. Virtual object means real object is not present. Somewhere due to intersection of light, some image has been formed which is further acting as object. That is what is meant by virtual object. And best way is light rays will be converging at a point. So these are converging rays, not objects. These are converging rays. So this is how you have to identify. Fine. Last thing for image or images also, then you people can write. For real image, actually the rays will meet. We have seen this example also. From the focus, one ray was coming, from the center of curvature, one ray was coming. They were actually meeting below the principal axis, and an image was formed. So here also, here reverse will occur. What was which were the rays for virtual object will become the rays for real image. So like this you have it. So these are converging rays. Fine. So these are converging rays. Secondly, virtual image rays appear to meet. They are actually not meeting. We are producing them. Remember dot dot way. We do not represent it in with continuous line. Dot dot, you expand it, extend it, and rays appear to meet. So these are diverging rays. It's already written. These are diverging. This is how you have to identify. Like this. You will produce it and you will obtain the image. Fine, write down all these basic points. These are very short points. Deviation of the path means, see, if there was not a presence of this refracting medium, then what will happen? the light ray which was coming like this, it will go straight if there is no disruption. But because of a medium which is capable of producing refraction, the light rays deviate from its original path. Bending of light rays occur either like this at different angles depending upon the Snell's laws conditions that we'll see later. So deviation from their original path means this. Yes, class. The next topic is refractive density. Now see, refractive index is actually the density. When I use the term density right now, this means optical density. One density which you have, that is mass by volume. That is something else. Mass by volume, which we study density of a material. This is optical density. Optical density in the sense, if you are having a material, one glass is present, or if I have 3-4 glasses, one glass is present, one is divergent, one is converging, all these are present. Now tell me, if I tell you, if a ray of light is incident on it, how will the rays go back? Understood? Will the rays actually meet? Will the rays be deviating more? Like this if I have. So in such cases, it means it depends upon the optical density. Depending upon the optical density, different types of materials are present. So that is what is meant by optical density when I use the term refractive index. So it defines optical density of a medium. There are two types of refractive index which are possible. One is the absolute refractive index. Second is the relative refractive index. Absolute and relative refractive index. Now, when I use the term absolute refractive index, it says, see, basically ratio of two speed. Now, this meaning was physically. When I say the meaning mathematically, how do we write it? It's basically the ratio of either speed of two different media or wavelengths of two different media. Means wavelength in medium 1 divided by wavelength in medium 2, or speed in medium 1 by speed in medium 2. Fine, two media are present. This is clear. One medium is one medium wavelength, or the second medium's speed will be taken, divided by second medium's wavelength or second medium speed. This is clear. Two things are taken. Either speed you take or you take the wavelength. All right. Optical density, normal density, mass by volume, like it defines an object. If I say water's density, 1000 kg per meter cube, 1 gram per centimeter cube. Now water's density is fixed. If I change the density, if I say 13.6, that is the density of mercury. That is the density of mercury. So it means material has changed. Something has occurred in the material. Right. Similarly, when we use the term optical density, that will tell you how much a light has been deviated, how much refraction has occurred, what is the speed of the light within the glass, within the medium, refractive medium which you have taken, what is the wavelength. It is also of two types, refractive index, absolute and relative. This is what I have said till now. I was saying two different media are there, so two different wavelengths ratio or two different speeds are taken. When I say refractive index, absolute refractive index, so this is refractive index of medium with respect to vacuum. If you have one medium, out of the two media, one medium is air, then this is absolute refractive index. If both the media are unknown, medium 1 and medium 2, that is relative. If out of the two media, one medium which is air or vacuum, then this is the case of absolute refractive index. We either represent it through n or nu. These two are given. So speed of light in air you are taking, so speed of light in air is c divided by speed of light in medium, the second medium which I was mentioning, c by b. Similarly, this is the same for wavelength. Wavelength you're taking in air, so this is wavelength in air by the wavelength in the medium m. Fine. So how do you write it? N or mu, whatever you are comfortable with, because reference books, if you will see NCERT, different authors have mentioned the different symbols. So you should be aware that both of them depict the same quantity. C by V, value of C you all should remember, speed of light is 3 into 10 to the power 8 meter per second, or wavelength in air lambda naught by lambda m. This is the formula which will be saving you in case of absolute refractive index. If this is the case of relative refractive index, so this is both of them, either V1 by V2, 1 medium, 2 medium, which is equal to lambda 1 by lambda 2 simply, whichever medium is mentioned. So lambda 1 is wavelength in one medium, lambda 2 is wavelength in medium 2, V1 is speed of light in medium 1, V2 is speed of light in medium 2. Just one thing, when we write N2 divided by N1, refractive index of 2 with respect to 1, not the speed, not the wavelength, refractive index of 2 with respect to 1, that is written usually as N21, because you will be expanding this. N21 is given to you, N12 is given to you. So when we say N21 means N2 divided by N1. Refractive index of medium 2 divided by refractive index of medium 1. N12, refractive index of medium 1 by refractive index of medium 2. N12. N12 is N1 divided by N. This is how we write. Note down the theory part for this. I mostly use N, Fia. I mostly use N.
It's lambda naught or lambda A?
Any you can use lambda A. I have just written for air. Lambda not. See, mostly for air we write this symbol not. So that's why not if you write it's better rather than A. Fine, all those who have completed, you all can leave. Tomorrow we'll continue.